Welcome to ID Lab, where we are hosting the joint experiments of the POE2 demonstrators. So here on this table, you see the functional demonstration of POE2. I will come to that later on. Let's walk through this demonstrator from the input to the output. So on my left side, you see the user interface of the arbitrary waveform generator that we are using to create two data streams that we provide to the analog multiplexer. So with the arbitrary waveform generator, we do some pulse shaping and re-equalization in order to create high quality signals for the analog multiplexer and to compensate for the losses and signal distortion that we see through this coaxial cable array. So on the board, we then see the transmission lines going to the electronic chips. So on this board that was designed by Fix assembled the transmitters chips, the receivers chips, the photonic chips, and the PolyBoard. It then connects to the fiber array. On this board, you then see a fan out going to all our power supplies. So the power supplies provide biasing for the optical elements, provide the different supply voltages that we need to make the chip work. And then we also see the digital interface that we use to program the chip. So on the laptop, you then see the many settings that we have to configure the circuits inside the chip in order to make sure that the signals have the appropriate levels, that we retime the signals properly, that the timing fits well, and that we can trade off performance with power consumption, for example. On the smaller laptop there, you then see a close-up of the EML wire bonded to the transmitter chip. So the wire bonding was done very shortly. So with this wire bond assembly, we have already achieved 100 gigawatt operation with quality. For the optical side, I will then give the word to our colleague Snatis from ICCS.
Thank you very much, Johan. So as Johan explained, the EMLs generate the optical signals on chip, on the optical chip. And then these optical signals get routed through this fiber array through the rest of the optical setup. Firstly, we have a transmission, a fiber transmission of 1 kilometer length, which you can see here. And then the signal is fed into a fiber amplifier, which amplifies the signal, compensates for the noises. And then we use an optical filter, a passband optical filter, in order to filter out some of the noise that is generated from the amplification stages. We use a tap monitor to be able to monitor our optical signal in real time using this optical spectrum analyzer. And we use a photodiode to detect the optical signal and generate the electrical signal. From the photodiode, the electrical signal gets routed to the sampling oscilloscope, which you can see right now, where the PAM-4 signal, the PAM-4 signal is sampled in real time. Now we're going to clear the oscilloscope and see how the oscilloscope samples the PAM-4 signal in real time. This run. Now we're going to see different diagrams on top of one another of what the gigawatt PAM-4 signals to POE2 demonstrator.